So now we have discussed the gradient boosted technique. The image that I have taken from the Wikipedia, the screenshot that is taken from Wikipedia. That screenshot I am taking from this. So I think it will be better if we just elaborate these things that is already discussed clearly in Wikipedia based. Just visit Wikipedia and search gradient boosted technique, then you can easily find this. Okay, so let's see how this actually internally work actually. So already we have seen that these things already we have seen actually our data sets is look like that already in our previous lectures when we have discussed the intuitions of the gradient boosting technique. So in that lecture already we have seen this thing. So our job is with this is our data sets, and these data sets we have to find a loss functions, and already in previous lecture I am taken the instead of m I am taken here k, our number of base learners. Okay, but let's take with the same example that's taken here. So here am is the number of base learners, okay, means number of iterations that we have to do the iteration. So and the loss functions is here, loss function is L of y f of x. That's thing already we have seen. The loss functions is look like that, and after some iterations that models we have to build f of x. So this is the simple input. The first input is, so just write down the first input is, so what is our first input? So our first input is the number data set, and the second input is the loss function. And also we have to mind that our loss functions is obviously a differentiable function. Okay, so if you just remember for logistic regressions we have taken the logistic loss. For linear regressions we have taken the square loss, and for SVM we have taken the hinge loss. And hinge loss is look like that, this kind of thing actually we have seen in hinge loss. This kind of function we have seen in hinge loss, but here somewhere it is not differentiable, but there have some hacks how to omit these things, how to reduce, how to differentiation. There have some approximations in these regions. Okay, we have already seen these things. So this kind of loss functions already we have studied. Okay, so this is the, so the main advantage of the gradient boosting is that there here we can use any kind of loss function that is differentiable. Okay, so this is the main advantage from the gradient boosters. So in initial model we have to assume the f naught functions. Initially we have to assume these f naught functions, this f naught we have to assume. And in f naught x means what? It means we have to argument, we have to find this gamma, suppose let's take, we have taken our loss functions. Suppose let's take for an example our loss functions, we have taken the square loss. This means this, now if we just taken the square loss, this L of yi gamma is means what? This means yi minus gamma whole square. This things is means what? This one. And now we have to find the summations over I is equals to 1 to n, and summations we have to minimize these functions, these overall functions, we have to minimize these overall functions. Okay, these overall functions we have to minimize this thing, we have to minimize these overall functions, and minimize will be like that, that the gamma value of this function, the gamma value of these whole functions, also the responsible gamma that minimizes this whole function. So that we have to carry. Okay, this is the simple our initial stage. Now here our number of base learners is m. So we have to iterate this process up to m stage, okay. Up to m stage. Suppose let's take this is this is our sample, m stage, this means what? Actually, if you just see this, if you just see this thing, this f of x means what? Just right. This f naught x means what? This f naught means our initially assumed model means h naught of x, these things means that already we have seen h naught of x. And now after initial stage we have started our iterations. So suppose they are here this thing, this iterations will help us to build the iterative model hm of x. These iterations will help us to build this hm of x model. So the how we'll build these models already we have seen by using the data sets. Using the data sets look like that, xi and error I, and this error I is coming from our previous stage. Okay, this error I is coming from our previous stage. That's actually the boosting technique works internally. Now here instead of boosting technique we are using the gradient boosting technique, means we are using here the gradient of the loss functions. Okay, this is the, and loss functions means gradient boosting means what? Here we have using actually the pseudo residuals. These things actually called the pseudo residual. So and RIM, this thing is called the pseudo residuals. These things actually called the pseudo residuals. Means this RIM is called the pseudo residuals. And RIM means what? RIM means it is the ith data point after m at the m stage. At the mth stage, these things mean at the mth stage and ith data point. This RIM, this pseudo residuals is at m stage and either ith data point. Okay, and for every iterations, first we have for when m is equals to 1, we have built h1 of x. When m is equals to 2, here we have built h2 of x. When up to 2, when iterations m, we have built hm of x. These iterations actually we are doing these jobs here. Now the questions is here. So actually in input, the loss functions, we have already assumed that our loss functions is differentiable functions. Okay, we can easily doing these jobs and we can easily find these jobs. Now the questions is, what is this f of xi? What is this f of xi? This f of xi means nothing. This f of xi is means simply coming from this f of xi is simply this f of xi is coming from the previous iterative functions. So f of xi is simply this f of x is simply coming from of the previous iterative functions, previous iterations, f of f minus x. Okay, that's already we have seen. And this value is calculated up to n number of data points. Here actually capital N is number of base learners and n is the number of data points that we have taken as input data. Okay, that's things we have to calculate it. Okay, now this is the first stage, first iteration stage. Okay, so for every iteration, this is the first stage, first sub stage. Okay, this is the first sub stage for single iteration stage. Okay, this is the first sub stage. Now in the second sub stage, what do we have to do? In the second sub stage, we have to feed our base learners. We have to feed our base learners. Base learners means what? Here base learners means hm of x. So first base learners is initially base learner is h naught of x. Then at the first iterations we have built our base learners h1 of x. Similarly, we have to suppose let's take we have here common here general iterations. Let's take m. At m small m iterations, we have built our base learners hm of x. So now our work is we have to feed the base learners or sample base learners or an example, the base learners, if you just take the gradient boosted decision tree, our base learners is a decision tree. Simply show h of m's to the pseudo residuals we have to fit. So fit to train, how we will fit to train these models. Actually we have seen to train these models we have using the data sets xi into error I. So here error I means what? Here error I means pseudo residuals error. So our in the gradient boosting technique, our data sets will be look like xi into rim, this kind of pair of data sets we have to take to build to train our base learners model. Here I will be 1 to n. I will be 1 to n, and n is responsible for our m stage, and this m is moving from 1 to m, capital M. Okay, and this by using this data set, by using simple these data sets, we will build our base learner model. Okay, we will train our base learner. Now after build the base learners model, now we have to compute the multiplier, this term, multiplier term, gamma of xi, gamma of m, by solving this optimization problem. By solving this optimizations problem means we have to calculate this gamma I by solving these optimizations of L of yi f of m minus 1 xi plus gamma of h m of xi. That's optimizations problem we have to solve, and it is coming from what? It is coming from 1 to n for n number of data points. Okay, and we have to find its minimum value, which is responsible for gamma, argument of minimum response. So this gamma we have to find. Okay, this gamma we have to find overall. So after finding this gamma value, we can easily build our next model at the end of the mth iterations. We can easily build. So before mth iterations, what we have find? We have find our model m minus 1 x. With the help of these models, we have calculated our pseudo residual that already we have seen. Now after before and end of the m stage, before m stage we have built these things, and end of the m stage, end of mth iterations, what do we have to find? We have to find this fm of x, and how these things will be find? These things find by using this formula, x m minus 1 x plus gamma m, that we have find from this substage 3, that we have find from substage 3 by simple. Now we have to add here the base learner models that we have find at the m stage, base learner model, simple base learners, that is simple by training using this data set, base learners that I have built by using these data sets, xi into rmxi in pseudo residuals, that we have built hmixi. That simple job we have to do to find the f of mx, fmx at the end of the mth iterations. Okay, that just continuing doing this job, just continue, you have to doing these jobs. So up to mth stage, that's the continuing we have to doing these jobs up to mth stage. Up to n stage. So at the end of the day, at the end of the m stage, at the end of the day, what actually we have finally got? We have finally got fm of x. So simply f of x means what? F capital M of x means f of m minus 1x plus gamma capital M minus 1 into h m minus, sorry, it will be capital M minus 1 x. So this is will be our final output. This value will be our actually final output. I think you have understands how this iterative gradient boosting technique so work internally. So if you just recap these things again, it is so easy and brilliant technique that we can easily use any kind of differentiable loss functions here. This is the main advantage of the gradient boosting techniques. So how these things actually work? First, we have to take just recap these things. I think from left side I am writing. So first we have to take. So first we have to take the input. First we have to take the input, and here input is what? Input, our first input is our data set. The second input is our loss functions. And also we have to remind that this loss functions is obviously differentiable. Obviously it will be differentiables. Now we have to enter the iteration stage. In iteration stage, we have to iterate this thing up to first in iteration stage. We have to build first the initial model. We have to first build an initial model. Initial model means what? Initial model means we have to assume our first f naught of x. F naught of x means simple, it is the arc mean of a simple arc mean of the I is equals to number of data points up to number of data points into L of yi gamma. That we have seen. If we take in the square loss, then our Li gamma will be like that. Okay, this is the initial stage. We have to find the gamma, overall gamma. This will be our the first initial model. Okay, after that we have to start these iterations from 1 to up to capital M. This is the initial stage. This is the first iterative stage. Okay, in this iterative stage we have to divide this iterative stage in subcomponents. So the subcomponents will be look like that. So in sub stages we have to compute the pseudo residual for each iterations. So first we have to calculate the pseudo residuals RIM. This is the sample we have to computed this RIM. Okay, and this RIM we have to calculate it for HI. For HI, I is equals to 1 to n. We have to calculate it, this RIM. Okay, and in second stage, in second sub stages, we have to build our base learners models. Means we have to build our base learners models HM of X by using these data sets XI RIM, where I is coming from 1 to n. Is coming from 1 to n. Okay, this is the second substage. In the third substage, we have to compute. In the third substage, we have to compute the gamma that which is responsible for minimizing the loss functions. So we have to compute the gamma m that which is responsible for minimizing the loss functions, additive loss functions. Loss functions means what? Here loss functions, updated loss functions actually will be, or initial loss functions is what? Initial loss function is this one, L of yi, L of y comma f of x. After updated these things, we have considered m stage, and already we have built means m minus 1 stage. already we have m minus 1 stage, plus also we have built the find the gamma that we have taken from here previous stage into base learners models that we have built from here. This is the simple updated loss functions now. This is the simple updated loss functions. Already we have the gamma value, already we have the this h of x value, this value, already we have these things. Don't worry about this. So sorry, it will be yi. Now we have to summations, we have to use the summations over I is equals to 1 to n, and we have to find its arc minimum. Arc mean, where mean is coming from gamma to gamma. This is the simple job we have to do in iterations. And after finding this gamma value, and finally we have to calculate it at the substage, fourth substage of these iterations. We have to calculate it the f of m value, fm value. And if m value, that how this will be calculated, this will be calculated by simple this formula. If m is equals to f m minus x plus gamma of m of h mx. These things actually calculate. This simple, this four stage we have to do in its iterations. And after completing the full iterations, and we have in final stage, after completing the edge iterations and in final stage, what do we have to do? We have to, at final stage, we have calculated this value f of m of x, and this will be our output, final output. Okay, this simple job we have to do. These simple jobs. First, you have to take the input variable that is taken the two types. First one is data sets, and second one is the loss functions that we have to choose. And to choosing the loss functions, we have to mind that thing that our loss functions obviously will be a differentiable functions. Then we have to start the iterations. And after starting the iterations, first initially we have to find the arc minimum of gamma. And this arc mean of gamma for the initial loss functions, that also will be our f naught of x. And after finding this f naught of x, we have to start our iterations. That iterations will be running from 1 to m. M means here our number of base learners. First, in the substage of this edge iterations, first substage, what I have to do, we have to find the pseudo residual value for each point, for each data points. Okay. And after that, using the pseudo residuals and data points, we have to build our base learner model, that is hm of x. We have to build these base learner models after finding this, using this data. And after finding these base learner models at mth stage, we have to find the arc mean of the gamma, means the gamma which is responsible for the minima is the updated loss function. This is actually our updated loss function. Okay, after finding the based gamma that's minimized our updated loss functions, using this gamma and base learner model and the model that is built from our previous stage, we have to build this fm of x. At the end of the mth stage, we have calculated this value. Okay, and after the job is iteratively processed up to capital M, up to number of base learners model. And at the end of the day, we have calculated capital M of x. That will be our the final output. Okay, these simple iterative jobs we have to do in gradient boosted. So I think the concept of gradient boosters is clear all of you. Although if you have any problem, please go to the Wikipedia page. There everything is clearly explanations, and I'm taking this material from the Wikipedia. Okay, just I request you, please go to the Wikipedia page and read this article. Okay, after reading this, I request you, please see this video. Then I think then the concept of the gradient basement will be much more clear.